Don Markholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 70 for the week of May 5th, 2021. The related website for this podcast is donmarkholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, May 5th, the moon is 30% full in our morning sky. The moon will be new on Tuesday, May 11th, late in the day. As we near May 11th, the moon is far south of the sun, meaning the southern hemisphere is favored for seeing the very thin crescent moon just before new moon. But if you want to see the thin crescent moon in the evening sky after new moon on May 11th, then look for it low in your western sky after sunset. The next night, May 12th, the moon will be right next to the planet Venus, both about 12 degrees from the sun. That means they set about an hour after sunset while there's still some twilight in the sky. In the evening sky, the planets Mercury and Venus both become visible. Mercury, magnitude 0, is emerging from evening twilight. Venus is below Mercury by 8 or 9 degrees, but Venus is much brighter. On May 28th, Venus catches up with Mercury, and they will both be in the same field of view. In the morning sky, we have the summer Milky Way running from north to south. Will you be able to see the International Space Station this week, which, for our purposes, begins Wednesday, May 5th through Tuesday, May 11th? It all depends upon your location. This week we have 6 zones. All you need to know is your latitude. Between 38 degrees north and up to 63 degrees north, the International Space Station will be in your morning sky all week long, sometimes twice per morning. Head further south from 33 to 38 degrees north. You can see the ISS in your morning sky, but only for the last few days of this week. From the equator to 33 degrees north, you will not see the International Space Station at all this week. South of the equator, the further south we go, the greater the visibility of the International Space Station in your evening sky. Now, near the equator, you won't see it until the last day of our week, May 11th. By the time you get to 33 degrees south, the ISS will be in your evening sky all week long. South of 40 degrees south, the ISS will be in your evening sky, but only for the first few days of the week. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Comet 2020 R4 Atlas is now high in our evening sky, moving 2 degrees per day. It outburst in the past week and is presently about 9th magnitude. It's moving away from both the Earth and Sun and is expected to be magnitude 11 by the end of May, so this week is a great week to get out and see it. The Finder map for Comet 2020 R4 Atlas can be found on last week's podcast, podcast 69, map 3. The positions, that is the right ascension and declination of this comet, can be found on podcast 66, Comet Positions. You can also get the present position of this comet from heavens-above.com. The Eta Aquariid meteor shower is still active as this week begins. The radiant is in the morning sky on Wednesday, May 5th, but it is about 15 degrees north of the crescent moon. You might see between 10 and 15 meteors per hour from the Eta Aquariids. Now for the astral class. Eclipses, both solar and lunar. So the moon goes around the earth, and every 29 and a half days it catches up with the sun. The moon can move up to 5 degrees from the ecliptic, that is the path the sun is on. So usually the moon passes north or south of the sun. But sometimes the moon passes right over the sun. When that happens, we have a solar eclipse as the moon blots out the sun as seen from the earth. The sun is about 400 times larger than the moon, and the sun is about 400 times further away. So the result is they both appear about the same size to us in the sky. If the moon is closer to us than average, then the moon will completely cover the sun, and we have a total solar eclipse. But get this, the moon hiding the sun can be seen from only certain parts on the earth, and this is known as the eclipse path. Those in this path, usually no more than 100 miles or 160 kilometers wide, will see the sun completely blocked by the moon for anywhere from a few seconds to 7 minutes. Do you live in the path of the next total solar eclipse? Get ready for a discouraging answer. Probably not. Just being honest here. But for every eclipse, thousands of amateur astronomers and astronomy enthusiasts travel to the eclipse path just to witness a total solar eclipse. And believe me, it is worth it to view the experience of a total solar eclipse. The sun completely disappears, and we are left with a hole in the sky surrounded by the areas beyond the limb of the sun, known as the solar corona. It is breathtaking. Nearly everyone else within a few hundred miles will see a partial eclipse. The moon covers only a portion of the sun, leaving a lot of bright sun shining through. A partial eclipse is interesting, but not as great as a total solar eclipse. Now, sometimes the moon is farther away from us than average, or even just average distance, and therefore it appears smaller in the sky. Smaller than the sun. Then if they line up exactly right, we get an annular eclipse, and at the right time, that is within the eclipse path, and on the central line, we see a ring of sun around the dark moon. Very interesting. This is called an annular eclipse, not because they occur annually, but because they produce an annulus, or ring, of light around the moon, nicknamed the Ring of Fire. Again, those outside the central path get to see a partial solar eclipse. Then there is a rare hybrid eclipse. It starts or ends as an annular eclipse. But when the sun-moon combination climbs higher in the sky, the moon's a bit larger and we get a total eclipse for a short time. As I said, some amateur astronomers are eclipse chasers. They plan their vacations around each total eclipse and make the expense to be there at the predicted time. The next total solar eclipse is December 4th, 2021. That is late this year in Antarctica. Okay, December in Antarctica may not be bad. The next total solar eclipse is April 20th, 2023, about 2 years from now, and it will be visible in the northwestern coast of Australia, Indonesia, and a lot of ocean. The total eclipse after that is April 8th, 2024, and that might be of interest to many of us. It starts in the Pacific Ocean near the equator, well south of Hawaii, cuts through central Mexico, then enters the United States through Texas and covers many states up through northern New York and Maine. That is April 8th, 2024. Start making your plans now if you live within driving distance. As for annular eclipses, on June 10th of this year, in about a month, there will be an annular eclipse in Russia, Greenland, and eastern Canada. The next annular eclipse after that is October 14th, 2023, 2.5 years from now. The United States will see this one as it enters on the west coast, south of Portland, Oregon, then through Nevada, the four corners of the U.S. where the four states meet, and exiting the U.S. at Corpus Christi, Texas. Then it goes through parts of Central America and then through Colombia and Brazil. That's in 2.5 years. A annular solar eclipse, October 14th, 2023. Between now and then, there are several partial solar eclipses, where parts of the world will see the sun only partly covered by the moon. As they approach, I will discuss them in these podcasts. So that's solar eclipses. Now let's talk about lunar eclipses. A lunar eclipse is not when the moon goes behind the sun, as that does not happen as seen from the Earth. Instead, the moon goes through the Earth's shadow. Yes, we have a shadow. As we go around the sun, we cast a shadow into space in the direction opposite the sun. If you have seen satellites traveling across the sky from west to east in the evening sky, watch carefully. They start to disappear when still well above the eastern horizon. That is because they have entered the Earth's shadow and there is no sunlight to reflect off of them. The Earth's shadow extends way out into space, nearly 4 times the distance to the moon. As the moon goes around the Earth, it usually goes north or south of this area every full moon. However, sometimes during a full moon, the moon will go right through our shadow. And then some strange things happen as we have a total lunar eclipse. The sun's direct rays do not reach the surface of the moon. Instead, the only light that reaches it is sunlight bent by the Earth's atmosphere. By the way, if we had no atmosphere, the moon would disappear. But we have air, and the moon gets some light. That light is usually orange or red, so the moon will often appear orange or red, or sometimes pink, and it might be light or dark depending upon our atmosphere. That is because the red light is refracted more by our atmosphere than blue light. It bends more, for example, in a prism, so the red light reaches around our planet and illuminates the moon. Get this, and I've never heard anyone mention this before. Those of us who watch the International Space Station in binoculars or a telescope and watch it until it dims as it goes into the Earth's shadow, notice that as it dims, it turns a certain color. You want to guess? Yes, orange, then red. That would be expected. As the International Space Station sees the setting sun, the sun appears to them to be red. If you have never noticed that before in the ISS, the reddening of it as it enters the Earth's shadow, look for it next time. But I have digressed. Back to the moon. If we have a dusty atmosphere, for example after a major volcanic event, then less light reaches the moon and it will appear darker than normal. The eclipse path for a lunar eclipse is big, about half the Earth. Whoever can see the moon can see the lunar eclipse. Actually, since the total phase can last about an hour, About 13/24 of the Earth can see each total lunar eclipse. Now that describes a total lunar eclipse, but not all of them are total when the moon goes through the center of the Earth's shadow. Some lunar eclipses are partial, when the moon goes through only a portion of the Earth's shadow. At that time, the coloring of the moon is not very noticeable because we are contending, even at the middle of the eclipse, with a bright lunar surface next to the darker surface. And then there is the third kind of eclipse, the most frequent kind, the penumbral lunar eclipse. Here the moon goes through the outer shadow that the Earth casts, where part of the sun still shines on the moon, and the moon has only a subtle darkening. If someone did not tell you there was a lunar eclipse, you would probably not even notice it. The next total lunar eclipse is set for Wednesday, May 26th, later this month. This one will be over the southern Pacific Ocean in most of Australia and Indonesia. The center of the eclipse is at 11:19 Universal Time, which is 7:19 Eastern Daylight Time, and 4:19 Pacific Daylight Time in the morning. So ask yourself, where is the full moon at that time from your location? On the west coast of the Americas, the moon is setting barely above the southwestern horizon at the time of total lunar eclipse. On the east coast of the United States, it will have already set and it will be daylight. But you will see the beginning of the eclipse before the moon sets. Further west, out in the Pacific Ocean, and especially the southern hemisphere, the moon will be higher in the sky. As far as total lunar eclipses go, this one is rather wimpy. The moon goes through the northern portion of the Earth's shadow, and the total amount of time the moon is fully in shadow is only 14 minutes. Our next lunar eclipse is November 18th and 19th of this year, but it's only a partial one. This one is sort of strange, as the moon gets 97% of the way into the Earth's shadow. Nearly a total lunar eclipse, but not quite. We will discuss that eclipse more as we get into November. Next week, I'll discuss constellations. Our binocular and telescope object this week is the spiral galaxy M106. It is located south of the Big Dipper. It's nearly overhead as the sky gets dark these evenings. And it's indicated on Podcast 70, Map 1 and Map 3. M106 is magnitude 8.8 and measures 11 by 5 arc minutes in size. It is about 22 million light years away, about 4 times the distance of M81. But that's about half the distance to the Virgo galaxies. Through binoculars, it should be visible under good conditions. It's the only galaxy in the immediate area. Notice the elongated shape through binoculars. Through a telescope, the weak spiral arms should be visible. They are brighter in the north than in the south. Crank up the magnification and look for detail in the nuclear region. To recap the podcast, what's up this coming week? The moon will be new at the end of this week. As the moon enters the evening sky, it will be next to Venus next Wednesday, May 12th. Comet 2020 R4 Atlas is easily visible in our evening sky. And get out and see M106. You have been listening to Looking Up with Don, podcast episode number 70 for May 5th, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's up in the sky, and in our astro class, we will learn about constellations. We'll look at another object in our evening sky. All that and more. Thank you for listening. See the sky this week. I'll see you